Today I am building a custom 2-piece vise for my mini milling machine. The reason? This massive cast iron round won't fit in my current vise, no matter how I try. Even turned sideways, it's just too big. So instead of trying to force it, I'm doing something different. I am using the full length of the milling table itself, with a custom vise that spans across it. But here's the catch. I'll have to machine some very tough high carbon steel on a mini milling machine. Let's see how that turns out. Also, jaw lift. It's the silent killer of vices. If I don't prevent it, this entire project could be a waste. The build starts with a 50mm round bar of cast iron. It was the only form I could get it, so I chopped it down the old-fashioned way, with a hacksaw. The pieces must be long enough to cover the table, but short enough to fit in my milling vise, with the hard jaws removed. To square the ends, I used my mini lathe. The pieces were barely held by the chuck, so I took very light cuts. I started with inserts for steel, but the chucker was awful, not worth the risk. Switching to sharper aluminium inserts smoothed things right out. With the ends squared up, it was time to head to the milling machine. The goal now was to turn these rounds into rectangular blocks. To save my slitting saws, I used a tungsten carbide wood cutting blade on a homemade arbor. Since the blade flexes under full depth cuts, I made multiple shallow passes. Then switched to finish the cut from the other side. Once I had two flat enough faces, I could finally clamp the stock properly. Now the real machining begins. With my upgraded mini mill, more torque, more rigidity, I used the face mill to clean the surface. The result? Decent finish, even with a fast feed. Then I flipped the stock and took a single deep cut to bring it to final thickness. After that, I squared up the remaining sides to final dimensions. I cut the moving jaw to 10mm thick, though, in hindsight, 15mm might have been better for strength. Time will tell. Here are both jaws, the moving and the fixed, each born from those cast iron rounds. For the hard jaws, I used high carbon steel. It is tough stuff. I had to rough cut it with an angle grinder just to get started. This material work hardens easily, so I kept the spindle speed low, took light cuts and used plenty of cutting fluid. Still, this finish wasn't great. I planned a fly cut later to clean things up. After squaring the two sides, I mounted the blocks for milling the faces. Some sides had deep rust pits, so I had to take off quite a bit of material. To give you an idea of how hard this stuff is, I dulled a tungsten slitting saw blade just cutting it. Honestly, it might not even need heat treatment. To cut the jaws to length, I used a 10mm end mill. It just barely had enough reach for the 25mm thick blocks. At the slowest speed setting, I could take surprisingly deep cuts, even in the high carbon steel. I drilled and countersunk holes for 8mm Allen bolts, spaced to match the outer T-slots on the milling table. For the center hole, I drilled a 16mm counterbore to fit the bolt head. Then tapped it for an M10 bolt. To keep everything aligned and prevent rotation and jaw lift, I added dowel pinholes. I reamed the first one to 8mm, but oddly the dowel didn't fit, a bit too tight. So I drilled it out to 8.1mm and got a usable fit. For the second hole, I skipped the reamer and went straight to 8.1mm. It fit perfectly. Next, I drilled and tapped mounting holes in both the fixed and moving parts to mount the hard jaws. The mill's extra torque made tapping much easier. I actually tapped the holes under power using the spindle. Then I countersunk the hard jaws for M6 bolts. Time for some polishing cuts. Using a fly cutter with aluminium inserts, I cleaned up all the exposed faces. Even with manual feed, the finish was fantastic, nearly mirror smooth. I was worried that the fly cutter would struggle on the hard jaws, but the mill handled them beautifully. Easily the best finish on the whole project. With both jaws mounted on the table, I fly cut across the tops to make them perfectly level. A single, smooth clamping surface, so flat you can barely see the join. Now for the moment of truth, jaw lift. Using a dial indicator, I measured the deflection when tightening the moving jaw. The result? 0.1mm, or about 4/1000ths of an inch. Not perfect, but definitely workable. I'll take that as a win. And that's it. The custom two-piece milling vise is done. It's ready for oversized workpieces, like this huge cast iron round, and what else I throw at it in future projects. This design was inspired by this old Tony's two-piece vise, but I adapted it to fit the smaller footprint of my mini milling machine. Check out the next idea by clicking on the link on screen. And don't forget to subscribe if you want to see more like this. Thanks for watching. See you next time.